Have you ever looked up at the sky on a clear, sunny day and wondered why it's blue? It's a question that has intrigued humanity for centuries. From ancient philosophers to modern scientists, the color of the sky has always been a subject of fascination. We often take this beautiful sight for granted, enjoying the serene blue without a second thought. But have you ever stopped to think about the science behind it? The reason why the sky appears blue is a fascinating tale of light and atmosphere. The sky looks blue because of how sunlight interacts with our atmosphere. When sunlight enters our atmosphere, it collides with molecules and small particles in the air. It's not that the sun only sends blue light our way. In fact, sunlight is a mixture of all the colors of the rainbow. When we see a rainbow, we are witnessing the dispersion of sunlight into its constituent colors. We can see this rainbow of colors when light passes through a prism. This phenomenon is a beautiful demonstration of the complexity of light. This colorful spread is called the visible spectrum. Each color in the spectrum has a different wavelength, which determines its color. Blue light has a shorter wavelength and is scattered in all directions by the gases and particles in the atmosphere. This scattering causes the sky to appear blue to our eyes. Sunlight travels a long way to reach us. It starts its journey from the sun, a giant star in space. The light from the sun looks white to us. As sunlight enters the Earth's atmosphere, it encounters tiny particles of air like nitrogen and oxygen. This is where the magic happens. These air particles scatter the sunlight in all directions. But here's the key: not all colors of light are scattered equally. Blue light, with its shorter wavelength, is scattered much more than other colors, especially red and orange, which have longer wavelengths. This fascinating phenomenon of light scattering is known as Rayleigh scattering, named after the brilliant scientist Lord Rayleigh, who first explained it in the 19th century. He discovered that the amount of scattering is inversely proportional to the fourth power of the wavelength. This means that shorter wavelengths of light, like blue and violet, scatter much more than longer wavelengths, such as red and yellow. So what does this mean for our blue sky? When sunlight enters our atmosphere, it collides with molecules and small particles in the air. Because blue light has a shorter wavelength, it is scattered in all directions by the gases and particles in the atmosphere. This scattered blue light is what we see when we look up at the sky. It's like a beautiful game of cosmic billiards, with light bouncing all around. Imagine the atmosphere as a giant pool table, and the light as the balls being struck. Think of it like this. Imagine throwing a tiny ball at a bunch of larger balls. The tiny ball will bounce off in many directions, just like how blue light scatters in the atmosphere. The tiny ball will bounce off in many directions. This scattering effect is why the sky appears blue most of the time. That's similar to how blue light scatters. However, during sunrise and sunset, the sky can appear red or orange because the light has to pass through more of the Earth's atmosphere, scattering the shorter blue wavelengths out of our line of sight, and leaving the longer red and orange wavelengths. This is why we see such beautiful colors at dawn and dusk. The science of color is truly a marvel of nature, revealing the hidden wonders of our world. Now you might be wondering, if blue light scatters the most, why isn't the sky violet? That's a great question. It's a question that has intrigued scientists and curious minds alike for generations. While it's true that violet light has an even shorter wavelength than blue, there are a couple of reasons why we don't see a violet sky. Let's delve into the fascinating science behind this phenomenon. Firstly, the sun doesn't emit as much violet light as blue. The sun's spectrum is more intense in the blue region, which means there's simply more blue light available to scatter. Secondly, our eyes are more sensitive to blue light than violet. The human eye has 3 types of color receptors, or cones, that are most responsive to red, green, and blue light. The cones that detect blue light are more sensitive than those that detect violet. So, even though violet light gets scattered more, our eyes are better at picking up on the blue. This is because the blue-sensitive cones in our eyes are more numerous and more effective at detecting blue light. It's like having a filter on our vision that enhances the blue, making it the dominant color we perceive in the sky. This natural filter effect is a result of the way our eyes and brain process light. It's a fascinating interplay of physics and biology. The scattering of light, the emission spectrum of the sun, and the sensitivity of our eyes all come together to create the beautiful blue sky we see every day. So next time you look up, remember the complex and wonderful science that makes our sky blue instead of violet.